Hello everyone, welcome back to the learning field, and this is Chandan. So in this video or in this lecture we are going to solve the PDE of CSIR NET 2025 December paper, and these are part C questions. So in the previous video or lecture I have discussed about the PDE of part B. Fine. So those who are not watching this PDE solution, so I'll share the link in the description. Please go and check. You will find definitely a very good quality of solution techniques in this video. Now in part C, there are two questions comes. So there are two questions came. So two questions mean 2 into 4.75 marks. Fine. So 9.5 marks. Right. So and these the two questions are very beautiful questions, very beautiful. So the questions are not like same as it is, means some out of the boundary questions you can think, but the questions are very means you have to think about it after I provide the with solution of these two questions. Fine. So very nice question. So see the solution technique. I will provide the very unique solution technique. Fine. Very unique technique to solve these questions, because you have to think about these types of questions. Otherwise, it is a little bit difficult to solve the questions in the exam hall. So let's start. And before starting, I'm requesting you to all those who are not those who are new in my channel, please give a like to this video, share with your friends, and don't forget to subscribe the channel. So this is the first question. The question says that consider a boundary value problem. This is a Laplace boundary value condition, boundary value problem. Uxx plus uyy equal to 0 in this and this. So first going with before going to the options, I will provide one important thing. What is the question? So this the question is based on Laplace equation on a circular disk. This is the specifies the problem. This specifies the problem. This question is based on Laplace equation on a circular disk. After watching these types of boundary condition, and most common form of this equations like this, uh, the boundary is like defined as this equal to x y belongs to R2, which is given such that x square plus y square equal to a square, sorry, less than, this is less than a square. And another thing is the problem is defined as uxx plus uyy equal to 0 for xy belongs to this capital sigma, and u equal to some function of h into theta. This on the boundary xy belongs to the boundary delta sigma. So this is the most general types of problem, and in this case we consider the x square plus y square equal to r square, where we take this y by x equal to tan theta. Fine. That is x equal to r cos theta, y equal to r sin theta. So in these types of case, when actually the Laplace equation is provided on the with circular boundary, then for solving these questions, we have to use the polar coordinate system. Fine, polar coordinate. But here, the question is not asking about the solution; it about the existence of solutions and regarding the existence and uniqueness. So one you can say the statement says that it's very important that existence of this equation, I can say that BBP, existence of this BBP, these types of BBP is guaranteed. BBP means for the Laplace equation, okay, is guaranteed. Is guaranteed if the boundary, if the boundary is sufficiently smooth, sufficiently smooth, and the boundaries are boundary conditions are continuous, boundary conditions are continuous, that ensuring harmonic behavior. So what is this statement says is that the boundary should be sufficiently smooth and the boundary conditions are continuous, that ensuring actually the harmonic behavior. So if we see that to the boundary condition what is given in our problem, which is that it is defined on a circular disk, and since, and one more thing is also important, is that existence requires that the boundary conditions bases are well behaved. The solution exists. It says that the solution exists and unique. The solutions exist and unique for regions bounded by a closed surface. Bounded by a closed surface where the potential is defined. Or the potential is defined. Now, what do you mean by that potential? See, actually, this uxx plus uyy, this is equal to some Laplace equation is given, na? So here it is given that in the boundary condition, on that boundary delta sigma, some thing is defined, uxy equal to defined. If for any case, if this is hold for any volume, closed volume V, then what happened, this V is called the potential. And if this is defined on the boundary, this is defined on the boundary, that is in the x square plus y square equal to 1, this is the defined on the boundary, that means, and the existence equal that well behaved, the solutions exist and unique in the region bounded by a closed surface. See, here it is given that the closed surface here in this case is x square plus y square is less than 1. This is a closed surface, and the boundary, in the boundary, the potential, that is u is also well defined, which is given by e to the power x plus y. That means the solution is exists and unique. Fine. So based on the boundary condition, you have to say whether the solutions are exist and unique. Suppose if there is such type of boundary which is not a smooth curve, because it says we need smooth curve and the boundary conditions ensuring the harmonic behavior. Fine. So this is a very smooth curve. So that's why the solution exists as well as the unique. So that means this is not true. Now there exists a solution to BBB such that uxy equal to 1 plus e by 2 and 1 plus e cube by 3 in the total region. That is what is now in that case e sigma union delta sigma. This is the curve that is given by x square plus y square is less equal to 1. Now, since this is a harmonic, see this stands for a harmonic behavior, this equation. So, the existence and uniqueness says that the solution of this equation, Laplace equation, is unique, and it also shows the harmonic behavior. Now, you can apply that maximum modulus theorem, which says that if the curve is means this curve is smooth curve and there is no singularity, so that means what we say, that we can say that the maximum value occur at the boundary, right? So that means in this boundary of this curve the maximum value is occur. Now it says that option 3 and 4 says that a solution exists, and a solution exists to a boundary such that this equal this. Now the if we can find the maximum value which happens in the boundary x square plus y square equal to 1, and if the value of this a of these two any two options is less than that value, maximum value, that means we can say that in this range this solution, the value of this solution exists, right? Do you understand or not? So this question is very conceptual questions. Find, see this these two actually these two shows that this is a smooth curve. So that means the solution is exist and unique, and it shows the harmonic behavior. So if it shows harmonic behavior, that means we can say that the maximum value of these functions happens at the boundary, and since this is a uh, what boundary value of that is Laplace equation with a circular disc, then we can consider this x square equal to r square, these types of thing, to find the maximum value of this function, and this is happen on the boundary. So this satisfies means what we take. So we can take this x square plus y square equal to 1. That means we can take the circular condition to convert it in the polar is x equal to cos theta, y equal to sin theta. Fine. Now, what is the value of u? U equal to given e to the power cos theta plus sin theta. Now, since this is an exponential function and in this power cos theta plus I sin theta, so we know that if e to the power f theta happens, then behavior depend on this f, the u behaves. That means if f is increasing, then whole function is increasing. F is decreasing, then whole function is decreasing. Fine. So that means we now find the maximum value of this function. So if we take f theta equal to cos theta plus sin theta, then f dash theta, this is equal to cos theta minus sin theta, right? Cos theta minus sin theta. So f dash equal to 0, or equal, this means cos theta equal to sin theta, that means tan theta equal to 1. That means theta equal to pi by 4. Now this is the point where the maximum or minimum value happens. So f dash theta equal to, we get minus sin theta minus cos theta, which gives sin cos equal to minus 1 by root 2 at pi by 4. So f double dash pi by 4, this is equal to minus 1 by root 2 minus 1 by root 2, which is minus of root 2, which is less than 0. That means at theta equal to pi by 4 we get the maximum value, right? We get the maximum value. So at the maximum value means the maximum value of f theta is f theta max, which is equal to cos pi by 2 means 1 by root 2 plus, sorry, cos pi by 4 means 1 by root 2 plus 1 by root 2, which is equal to root 2. That means the value, that is cos theta, maximum of cos theta plus sin theta, which is equal to root 2. Now what we can say, that if this value, if this and this which is less than this value, that means e to the power root 2 value, we can say that now e to the power root 2 means the maximum value is e to the power root 2 of these functions. Now we can say that e is less than e to the power root 2. Fine. E is less than e to the power root 2. We actually develop the inequality of with this and this. Fine. So e to the power root 2, that means 1 plus e is this and 1 plus e by 2 is this. That means 1 plus e by 2, this value is less than 1 plus e to the power root 2 by 2. Since this is the maximum value, now if we develop this function, so this is less. That means this actually this value exist inside the our given region. That means we can say that since this is valid or satisfied, we can say that there exists a solution u with uxy equal to this for this region. Fine. So this is true. Now for 1 plus e to the power 3 by root 2, fine. So we know that e to the power 3 is greater than e to the power root 2. Since root 2 equal to, we can say 1.4. That means 1 plus e to the power 3 this by 2 by 2. So we develop this inequality also. That means this 1 plus root 3 by 2, this is greater than this maximum value. That means this value does not yeah, actually contained in the given boundary, which is this equal to this. So that means this is not exist. These types of solution not exist for the boundary value problem with satisfying uxy equal to 1 plus e to the power root 3 e cube by 2. Do you understand or not this solution? So this is a very unique approach to solve this question. Fine. I think this is understandable. If anything, if any portions of this solution method you are not understanding, then please let me know in the comment section below. That means A and C are the correct answer of this problem. Fine. Now next question. This is also a very beautiful question, very beautiful solution technique actually, which says that let uxt be the solution of the initial boundary value problem this, which is given for t greater equal to 0. Let us define e to the power t equal to this. Which of the following statements are true? Now all the options are given that for all t greater than 0. So t greater than 0, what do we mean by t greater than 0? T greater than 0 means t can go to up to infinity. And if t tends to infinity, then what happens? We get the steady state solution. Steady state solution. So this is the very important thing which is noticeable. So steady state solution we get. Now steady state solutions means what? We know that if u is the differentially u is the this function, then what do we mean by steady state function? Steady state function means del u del t, this is equal to 0 for this u, this, and what happened for the wave equation del 2u del t2, this is also 0. Fine. Since del u del t equal to 0, then this function is also 0. That means we get the wave equation which is given here is reduces to only in uxx equal to 0. If we integrate this, then we get ux equal to, suppose, constant c1. Again by integrating we get uxt, this is equal to c1x plus c2. We get this types of function by applying this, because of all four options are given here for t greater than 0. Now we get this one. Now if we apply the boundary conditions, what we get from the if we apply the u0 to equal to 0, the first boundary condition, u0t, this is equal to 0, this implies c2 equal to 0. Now if we apply this u pi t equal to 0, u pi t equal to 0, if we apply, then c1 is also 0, but we are not interested in this solution. So we have another boundary condition that we can apply, ux0 equal to 0, ux0, this is equal to, sorry, given sin x. So if we apply, then sin x equal to c1x, that is we can get from here is that c1 equal to sin x by x. Fine, we can get this one. So if we put that value uxt equal to, we get only sin x. Uxt equal to only sin x. Now if we do this integration, since ut equal to 0, therefore et is only equal to integration 0 to pi sin square x, sorry, cos square x dx, since it is given as ux. So this ut obviously we get already 0. So uxt equal to sin x. So ut from ux, sorry, from here we get ux equal to cos x. Fine. So here we get cos square x dx. So this means we can write half integration 0 to pi 1 plus cos 2x dx, which is, if we integrate, then we get half into pi, sorry, half into x minus x plus sine 2x by 2, the limit is 0 to pi. So this is equal to half into pi and sine 2 pi 0 and sine 0 0 half into pi, which is equal to pi by 2. So which we can write it that is exactly pi by 2. That means it is less equal to pi by 2. So that means pi by 2 exact value we already get, but pi by 2 value is not greater than pi. That means option 1 is incorrect. It is less equal to pi. Yes, pi by 2 value is obviously less equal to pi. This is correct. Greater equal to pi by 2. Exactly pi by 2 greater equal to pi by 2. Yes, this can also be correct. And e to the power t is less equal to pi by 2. Yes, this is also correct option. Therefore, here I get B, C, D. Three options are correct, right? So exactly pi by 2 means A, B, C are already the correct options. Or yeah, so these three options are correct. So these are the two questions that we already solved in this lecture. So what is the video? If the video is helpful, then please give a like to this video, share it with your friends, and don't forget to subscribe the channel. Okay, thank you.